1995, NASA attempted something no one had ever tried before. This is the Jupiter Galileo Probe, the first spacecraft to ever enter a gas planet. It performed one of the most complex space maneuvers of its time, and it was one of the most advanced pieces of technology NASA had ever made. This is the story of the genius design of the Galileo Probe, and it's the story of the first time we entered the king of planets, Jupiter. 147 days before entry, explosive nuts separate Galileo's orbiter from its probe. Spinning like a bullet from a gun, it heads to a target 81 million kilometers away. It needed to be shot just right, too steep and it would burn away before any valuable measurements could be taken, too wide and it would never enter to begin with. For now, it was on its own, on a one-way mission to gather the first samples of the largest gas planet in our solar system. 14 days after the release, the orbiter reoriented. It fired its engines. It redirects away from the path it set its companion on. From a distance, it could capture the data transmitted from the probe and retransmit it back to Earth. 9 days before entry, the orbiter powers on its antenna. Once the probe enters the atmosphere, it will only have minutes to find its signal before the data is lost forever. 6 hours before entry, the probe turns on. Its batteries flood the instruments that were dormant for nearly a decade. It has passed a point of no return, entering Jupiter's inner magnetosphere. It was a no-man's zone, an uncharted region filled with a vast array of unstudied and brutally energetic particles. The energetic particle instrument is the first to wake up. A small device, it begins to collect data, taking in its new surroundings, up to 3 million particles every second. As the EPI races against time, another instrument, sharing space in the cramped electronics box, also turns on. Years before, 2 night photographs taken by Voyager 1 on its flyby of Jupiter seemed to show evidence for a strange possibility: lightning. On Earth, the most understood form of lightning was the result of interactions between clouds and the ground. But Jupiter has no ground. It was unknown how Jovian lightning would behave. Protected behind a small radio frequency window in the probe's aft heat shield, radio waves could still be picked up. From it, the antenna for the lightning and radio emission detector, LRD, searched through the noise for the telltale radio signature of a lightning strike. The antenna was short, but radio signals were not enough to verify the existence of lightning. They needed light. 2 sensitive photodiodes mounted behind individual fisheye lenses, 180 degrees apart to maximize the field of view. 3 hours and 4 minutes before entry, 360,000 kilometers away, measurements of Jupiter's inner radiation belt began. For the next 3 hours, once an hour, the EPI and LRD instruments took rounds of measurements. They only stopped once they reached the edge of Jupiter's atmosphere, 16 minutes and 38 seconds before entry. The planet had grown on the horizon to take up the entire sky. It began collecting data about its surroundings. 3 minutes before entry, flying 214,000 kilometers above, the orbiter cycles into a new series of commands and the onboard tape recorder starts. Below it, the probe has begun its descent. A dart has been thrown 500 million miles into the center of an enormous interplanetary dartboard, and it was coming in hot, pulling 47.4 kilometers per second. The entire probe was 49 inches at its widest and 34 inches tall, but it weighed nearly as much as a vending machine. It was composed of 2 parts, an outer shell for deceleration and an inner module for the descent on a parachute. The shell was the outer deceleration module, its shape chosen to minimize weight, base diameter, and ballast. It had to survive and slow the probe enough for it to deploy its parachutes. Jupiter had no surface, not as we know it, just a never-ending storm of turbulent gas. Height in the sky of a planet with no surface is measured based on pressure. The altitude is measured relative to when pressure on the surface equals Earth at sea level, 1 bar of pressure. The probe entered Jupiter when it reached 450 kilometers above 1 bar. Entry. It was tough, but entering the atmosphere, it was only 0.4 kilometers per second slower than it was built to withstand. Any faster and the probe would burn up. Its arrival marked the edge of Jupiter's outer atmosphere, a mysterious cocktail of clouds that had never been directly sampled. The event triggered a short cylindrical device on board, and the atmospheric structure instrument starts to record. Made up of 3 sensors, it could measure temperature, pressure, and changes in acceleration as the probe's altitude changed through its descent. The probe was burning, 352 degrees Celsius. It was more than hot enough to destroy the instruments hidden within it. The outer deceleration module just needed to hold. It had been constructed in 2 segments, a heavy forward heat shield and a thinner afterbody heat shield. The forward heat shield, known as the aeroshell, was made from aluminum alloys and held the inner descent module in place. It was large, taking up nearly half of the probe's mass. On entry, the cone was aimed down, its nosepiece constructed from carbon phenolic, a material popular for re-entry vehicles on Earth. Its job was to burn, and by burning, transfer the heat generated out and away. The thinner afterbody heat shield, in contrast, was only 16 kg. The aluminum dome was held in place at its base by a ring, which connected it to the forward heat shield. Along it, each 120 degrees apart, 3 explosive bolts waited, ready for a rapid separation. 35 seconds after entry. For the next 15 seconds, the probe withstands the worst of its deceleration, pulling 228 Gs. In moments, it had traveled 230 kilometers, pressure around it slowly rising to 0.001 bars. So far up into the upper atmosphere, it should have been cold, but close to the probe, the heat was vicious. The front reaching temperatures more than twice the surface temperature of the sun. It was a man-made meteor. The heat shields began to break, leaving behind a trail of vaporized metal. 1 minute and 20 seconds after entry, the worst of the deceleration had passed, but with it, over half of the forward heat shield was gone, 90 kg lost in less than 2 minutes. The incandescent descent of the probe had now been hopefully slowed enough to prevent the parachute from being ripped apart when it opened. And at 0.1 bars, it was time. But something was wrong. The parachute hadn't deployed. 2 switches were cross-wired, their timings off. All that work and time for the probe to fail at its most important moment. Without a signal, the probe continues to fall, pressure rising, 0.1 bars, 0.2 bars. It plummeted, 0.3 bars. But at 0.41 bars, the probe snapped to life. Cables were severed, and the nuts holding the cover in place were fired, releasing it and pulling the pilot's chute into the wake, which, as it was pulled out, stripped the bag holding the main parachute. The aft heat shield fell away, into the rapidly cooling air in the probe's wake, minus 145 degrees Celsius, 2 minutes and 52 seconds after entry. Kilometers above Earth sea level, within moments, the pilot's chute yanked the main parachute free from its enclosure. The enormous main chute unfurled, and as it did, swiveling to decouple the deceleration and descent modules. Within 1.2 seconds, the parachute was free. To survive such a violent deployment at Mach 0.9, the main parachute was made from Dacron and Kevlar. 9 seconds later, the aeroshell was jettisoned with 3 explosive bolts. The probe was now floating through the strange sky of a gas giant, an unknown alien world. Instruments hummed to life, and the metallic arm of a new instrument deployed out of the freed descent module. The nephelometer, NEP, or Nephilah, Greek for cloud, was an instrument designed to study the composition of Jupiter's clouds. As the probe fell, it took measurements of the clouds every kilometer. The arm was only one part of the wide box. The reflector in the arm was used to scatter light emitted from the NEP's laser back into the instrument's detector. By measuring how the light scattered, it could study the physical properties of the clouds. The remaining descent module, hidden beneath a smooth shell like a pearl at the heart of a large oyster, was finally exposed to the atmosphere. 3 minutes after entry. Once the aeroshell had dropped 30 meters away, the remaining science instruments came to life. The descent module carried 7 in total. Each had been carefully selected for the first up-and-close encounter, with a suite of technology used to collect and transmit the data safely up to the orbiter, which in turn would transmit back to Earth some 778 million kilometers away. Altogether, the science instruments only made up 28 kg of the entire probe. The probe was 21 kilometers above Earth's sea level and falling fast, 650 kilometers per hour, as the temperature continued to fall to minus 145 degrees Celsius. The main parachute caught in the Jovian atmosphere, slowing the remaining descent module to 430 kilometers per hour. 3 minutes and 2 seconds after entry. The first direct sampling of Jupiter's atmosphere began, now at 0.42 bars. late due to the delay in launching the parachute. The probe collected all the data on board, its transmitter searching the sky above it for the orbiter. Without it, the data would be lost forever. Exactly 1 minute after the descent began, it locked onto the signal of its scientific companion. The probe had fallen another 4 kilometers, and the pressure had jumped to 0.56 bars in less than 30 seconds. Far above, the orbiter received the data via the relay radio hardware, a large 1.1 meter steerable parabolic dish mounted to the orbiter. 4 minutes and 8 seconds after entry. Within seconds, the orbiter received all the backup data the probe had accumulated on its long flight before entering orbit, now interwoven with the real-time data. The probe had shot through 450 kilometers of clouds and gas and was now reaching its own kind of summit as it crossed the atmospheric surface at 1 bar. With it, the cold outer atmosphere cloud layers had begun to give way to inner heat of the planet. The temperature had risen from minus 135 degrees Celsius to minus 107 degrees Celsius. It would only grow hotter from here. 9 minutes and 36 seconds after entry, the temperature had shot up again. At 1.6 bars, it was minus 80 degrees Celsius. Onboard instruments could retrieve information about Jupiter's makeup, but one had just triggered that would be able to tell a story about the beginning of the universe. When the outside pressure reached 2.5 bars, the thin metal diaphragm holding gas within the helium abundance detector had burst. This pushed a small needle device into the second diaphragm, mixing the reference gas and Jovian atmosphere together, rapidly taking measurements. Hydrogen and helium are among the most abundant elements in the universe, but the ratio of them early after the Big Bang was not well understood, making models difficult to construct. Gas giants like Jupiter were thought to preserve the helium abundance created in the Big Bang like an enormous time capsule. The HAD could continue to collect and compare data until the reference gas had fully expanded to the local ambient pressure at about 12 bars, expected roughly 30 minutes into the descent, if the probe made it that far. Shaped like a small bomb, data collected in the pressurized titanium housing of the neutral mass spectrometer was released. The first round of direct chemical sampling of an alien world were completed as the pressure rose to 3.8 bars, 22 minutes after entry. When the probe entered the predicted water cloud level, it was now 0 degrees Celsius and 5 bars, and the probe had fallen to minus 56 kilometers below the Earth 1 bar level. As the probe descended deeper through layers of cloud cover, changes in temperature led to regions of heating and cooling. These gradients can produce turbulent winds that plagues the planet and controls the circulation of the atmosphere. To measure the changes in temperature and flux, the net flux radiometer contained 6 detectors. The electronics box was bolted to the instrument shelf. An optical head extended out of the probe through the thermal blanket and aeroshell to directly view the atmosphere's radiation through a tough diamond window, with a small 300 megawatt heater to warm it up and prevent condensation buildup. Atmospheric chemistry changes with altitude, so now at 8.6 bars, the second round of sampling began. The probe had been built to withstand at least 10 bars, and 35 minutes into its journey, the probe had reached the end of its planned mission. And yet, the probe refused to crumble. 41 minutes after entry. Taking advantage of the reprieve, at 12.1 bars, the ambitious second round of NMS sampling finished as the probe continued its long heated path ever down. 49 minutes after entry. Well beyond its expected limits, but not wanting to waste the chance, a third round of NMS sampling began under an immense 15.8 bars. 51 minutes after entry. To avoid any single-point catastrophic mission failures, the electronics on board were heavy. They had been made to survive 20 bars of atmospheric pressure. The priceless data collected were transmitted on board with 2 parallel and simultaneous streams. But, suddenly, 51 minutes after entry, one of the transmitters stopped. For the next 12 minutes, the remaining transmitter fluttered, dropping off before suddenly rising back up. The beating heart of the probe was struggling, as the sealed box containing the transmitters had begun to deform under the growing pressure and temperature. 1 hour after entry. Silence. The mission ended in silence. On board, the heat had risen to 153 degrees Celsius. The probe had traveled 146 kilometers, far below where the mission had been expected to end. 20 minutes later, the orbiter turned off its receivers, stowing its antenna and moving on to join Jupiter's orbit and to begin its own perilous journey. Far below, once the probe had descended 650 kilometers, the temperatures would have become hot enough to vaporize metal. Piece by piece, the probe had begun to be dissected by the King of Planets. As it continued down, mute, each second the temperature and pressure rose. Another limb was claimed. First, the parachute melted. The descent module, now released from its slow descent, was free to fall. Aluminum fittings melted, and within hours, the aluminum itself had completely vaporized. 4 hours later, the probe's titanium shell melted with its instruments. 2 hours later, under the weight 5,000 times the surface pressure of Earth, and 1,700 degrees Celsius, even the titanium evaporated. The probe was gone, fully atomized, having joined as a very small part the planet it had been sent to study.